All right, so I'm going to talk about biological seed treatments for soybeans. This is a really hot topic that you'll see if you were at Commodity Classic last week. You would have saw dozens and dozens of products being sold. And this project is really a multi-state effort under a team we call Science for Success. So the Science for Success team is a group of soybean agronomists across the U.S., and we have funding from the United Soybean Board to meet a couple times a year, and we develop educational materials, fact sheets, we work on common research projects. So this is the biological seed treatment trial is one of many projects that we work on collaboratively. So these are some of the states involved. And we're all agronomists at land-grant universities, and really the goal is to deliver best management practices for soybeans. A lot of our individual research trials, though, within states are funded by the state's soybean checkoff. So in Ohio's case, that would be Ohio Soybean Council. And then we collaborate on these national research trials. So some that we have wrapped up, we did a national screen of foliar fertilizers. We looked at nitrogen application to soybean, sulfur application to soybean. And what I'm going to focus on today are biologicals. So we have 1 year of data for biological seed treatments on soybean. And really we want to amplify the state research across the U.S. with these collaborative protocols. And I'll put a plug in for the Science for Success team. We have webinars coming up. So we have one on Friday this week, and then 2 more Fridays after that. So kind of keep your eye open for that. I had a newsletter article in the core newsletter on Monday where you can register. It's free. You can get crop management credit, CEUs. So if you're interested in that webinar, the webinar topic is soybean replant decisions. Replanting, unfortunately, is a very common thing in Ohio. So if you're interested in that, catch our webinar on Friday. But I'll jump into our biological seed treatment trials. So really the reason we're doing this research is because the biological market has really increased over the past few years. There's a lot of expansion in this area and growth. And some of that is driven, I think, in part by the fertilizer costs. So the cost of nitrogen and phosphorus fertilizers in particular are extremely high. And a lot of these biological products promote a nitrogen fixation or increased nitrogen uptake, increased phosphorus uptake, things like that. So this is based on data from last year at Commodity Classic, but I had my student look at their trade show website and pick out every company that was selling a biological seed treatment for soybean only. And he found 22 different companies and 40 different products. And this was at one trade show alone. And we know that wasn't inclusive of all of the products available. So there's this huge market out there of biological seed treatments. And I call them active ingredients. There's multiple species, genus and species of these microbial products, Bradyrhizobia, Pseudomonas, Trichoderma, Bacillus. So all of these different ingredients that do different things to the soybean plant. This is a word cloud too of all of the labels. So we copied and pasted all the labels and saw what kind of rose up. But you'll see, improved seed germination, early root growth, fungicide, amino acid, sudden death syndrome, plant growth. So all of these different things that these biological seed treatments are marketed for. And again, some of those claims, improve nitrogen fixation, assimilate P, increase nutrient use efficiency and uptake, control of disease, nematodes, efficient root growth, root absorption of nutrients. So all of these proposed benefits. So this study is ongoing. So we have 1 year of data, but overall we have 2 objectives. We really want to see in what situations do these biological seed treatments improve soybean yield, and then also profitability. And then we want to also look at the status of the plant nutrient. Because again, a lot of these will improve root growth, increase phosphorus uptake, nitrogen uptake. So really, how does that change the nutrient status of the plant? What I'm going to focus on today, is really the yield portion, because that's where we have the majority of our data right now. Everything else takes a long time to work through. But this is the team from 2022. So we had 17 states across the U.S., which is a lot, and each state had multiple trial locations. So last year we ended up with 49 individual locations, which is a huge number, and we have good representation north, south, east, west. This year we added Nebraska, Pennsylvania, Maryland, and Florida. So we're going to have more states, so that's really exciting. We were kind of absent out here, like Great Plains area, but we're going to pull in Nebraska, which is exciting. So again, 17 states, we had 49 locations. Everything was in a small plot, so probably, depends on the state, 4 to 6 rows of soybeans. We had 6 to 8 replications, so this is more than our standard of 4, so we really wanted to try to get a lot of data here. And with the biological products, all of them were applied to a fungicide and insecticide treated seed, and that was Acceleron, because we wanted to have that baseline platform. So our untreated control was really just treated with fungicide and insecticide and nothing else. And we did check with all the companies to make sure there was some compatibility between that fungicide and insecticide package and their biological product. So we had 9 different products, and I'm not showing the brand name, I'm just showing the active ingredient here. But we tried to get a range of different genus and species of microbial products or biological products. And then again, we compared each one to the untreated control because these products do different things. So it doesn't necessarily make sense to compare Bradyrhizobium to a trichoderma because they don't do the same thing in the plant. So all of these products we compared back to the untreated control, which again was just that fungicide and insecticide product. So this is brand new data, hot off the press, so I haven't talked to anyone about this yet. So we kind of went a different direction with this research in terms of our analysis. So we hired a statistician to do this because 49 locations is beyond my statistical ability. So we had a statistician do some distributions and ran some models. So what you're looking at here, this is treatment 1. These are the species in treatment 1. So this is for Ohio only. So we had, in Ohio, in particular, we had 6 different locations. And this is the distribution, so the frequency of these yield responses. So this red dashed line is the yield difference, the treatment minus the control. So basically, this red dashed line means there was no yield difference between the control and the biological product. The black solid line is the average difference. So since the average yield difference is less than 0, we actually had a slight, on average, a slight negative response to this biological seed treatment. The caveat is the p-value. The p tells you the probability. So 33%, this is not a very high probability, it's a low probability, but 33% that there was on average that negative 0.7 yield loss with this product. Any questions about how this is set up before I move on to the rest of them? All right, everyone understands Bayesian statistics now? All right. I thought it was a nice visual. Honestly, I have no idea how they did it, but I know that you can make a lot of money if you know how to do statistics. So a lot of money, because I paid a lot for these graphs. So the next one is trichoderma. Again, 0 is no difference between the control. Here again, there was a negative response. This was 1.5 bushels. Again, extremely low probability, 15%. Not high confidence, not a high probability, but on average there was a reduction in yield. Bradyrhizobium, so this is our standard inoculant. So Bradyrhizobium japonicum is the microbe that will fix nitrogen from the air and make it available for the soybean plant. In Ohio, when we have soybean in rotation frequently, we don't see much yield response because we have adequate populations in the soil already. Here, again, another negative response, 1.4 bushels, but the probability was 17%. So very, very low probability. And these fields that we were in all were in that consistent corn soybean rotation. So if it was a field that was brand new to soybean, there would probably be a response and a benefit there, but with that corn soybean rotation, no real effect there. Treatment 4, these are the bacillus and then also Bradyrhizobium japonicum. And I hate to keep saying this, but again, on average, a slight negative response. Probability was very low though. Here it was 9%, so even lower probability of having that negative response. Treatment 5, so this one had a slight yield benefit. It was 0.2 bushels per acre, so this is our first slight positive. Not a huge yield response, but a little bit yield response. And the probability of that response was 56%, so a little bit stronger. Pseudomonas is our next one. This is treatment 6. This one had a slight yield penalty as well, 1.6 bushels per acre. But that was at 16% probability, so very low probability. Treatment 7 with some Bradyrhizobium, but not Japonicum. I think it's Alkini. So this one had a little bit negative yield response too, negative 0.4 bushels per acre, 38% probability, not super high. This is Bacillus, treatment 8. Negative 1 bushel per acre, probability on that was 25%. Not high, but slightly negative. And then treatment 9, the glomus is the genus on that, negative 0.1 bushel per acre and a 46% probability. So, yeah. So looking across the U.S. though, so Ohio is one state. We have data from across the U.S. So where do these things work, right? So we do have indication that there's a location by treatment effect. So that means the effect of these biological products is location dependent. And I think that makes sense in a lot of ways. So what we saw with our data is that we had a higher probability of a positive yield response in the southern U.S. So looking at Louisiana, Alabama, South Carolina, those states had a much higher probability of a positive yield response. So those states were more in the positive 2 to 3 bushel per acre range, and that was more with like an 80% confidence, so much higher confidence of a positive yield response in those southern states. The states that had no response, out of that 17 states with no yield response, Ohio was on that list. So the 3 states with no yield response were Ohio, Iowa, and South Dakota. So we did not have any treatments that had a probability of response over 60%. So very low probability of a response. The one treatment that showed the highest probability of response compared to the others was that trichoderma. That was treatment number 2. In Ohio, nothing that would be notable, but in the states listed here, so again, mostly southern states with the exception of Wisconsin. Wisconsin, for whatever reason, like pops up with the southern states, but Arkansas, Louisiana, Mississippi, South Carolina, Virginia, and Wisconsin, there was about a half bushel to 2.3 bushel per acre yield advantage compared to the non-treated control with treatment 2, which was that trichoderma. So in the northern states, the one that showed the highest likelihood of a response was treatment number 4, the Bacillus and Bradyrhizobium, and that was the one that was most significant in the northern environments. They had a positive yield response of 0.4 to 1.6 bushels per acre compared to the non-treated control. Was not significant in Ohio, but for the other northern states, there was positive yield response in Michigan, North Dakota, and Wisconsin. Also Mississippi and Louisiana in the south popped up as well. And the thing to keep in mind with these biological products, first of all, is that biology is really hard. So I've talked to a lot of these companies with these biological seed treatments. They were all very generous to donate products for this trial, which was not a small feat with 17 different states. So they're very generous. And biology is harder than chemistry because you have so many things that interact with that microbe. So this is the disease triangle, and I'm sure you've seen it from plant pathologists at Ohio State for many years. So to get a disease, you have to have a host, a pathogen, and an environment that promotes that disease, so the conditions that promote that disease. And I think you can think of biological seed treatments a lot in the same way. It's not necessarily a pathogen, but it is a microbe, and it is a microbe that needs to infect the root of the plant. So for these biological seed treatments to work or have a yield response, you have to have the biological on the seed and keep it alive. So in our trials, we were very careful to follow the instructions. We provided brand new product to each state that was unopened. We told them how to store it, how to apply it, made sure you did it within the constraints of the label and what we heard from the companies. But you have to make sure that this biological is alive, and it also needs to infect the root. So that you have to have the environment. So if your soils are maybe too dry, or maybe there are other microbes there out competing the one that you're applying, the environment may not be right. And then also you have to have the soybean plant. So you need all three of these things in order to get a response. So I think there's a lot of ongoing work that needs to be done in this area. Again, I was in Commodity Classic last week in Orlando, and there's a lot of development in this area. A lot of companies are putting a lot of resources and efforts into biological seed treatment, so I think it's really important to keep an eye on. And I know at Commodity Classic, when I met with the agronomists across the US, we all agreed collectively that we should keep evaluating these, because if there is a product that works somewhere, we need to find it and we need to know where it works the best. So it's work that's ongoing. Again, biology is a lot more challenging than chemistry. If you apply a fungicide, you know the mode of action and it should work, or a herbicide. But biology, you have to have a lot of factors that come into play to make the product work. The delivery technology research is ongoing, and I know Jane will talk more about that. But when I met with all of these companies, they're constantly tweaking their microbes, their systems, their delivery, their packaging. So there's a lot of work and efforts going on in that area. And then we also wonder too if there are differences in high productivity versus low productivity soils. So just thinking about the southern United States, their soils are much more weathered than what we have here in Ohio. So it's just really interesting to see more of those yield responses maybe in Arkansas, Louisiana, Mississippi. We're adding Florida this year. Florida has really crappy soil, so that'll be great to see if there's a yield response there. And also my student working on this project, he's from Brazil. And in Brazil, they use a lot of biological seed treatments, and the farmers are very happy and they see yield responses. So, you know, is there this north to south influence? Because you think about Brazil, Brazil would be even more weathered than what you would see in Arkansas, Florida, Mississippi, Louisiana. So that's one area that I'm really interested in too, is maybe these biologicals in Ohio or like Iowa, where we have pretty good soil overall compared to Brazil. Maybe they're just not as well positioned here as maybe they would be further south in the US or in Brazil or Argentina even. So this is my student, Fabiano. He's been working on this project. So he's been great to have. And he does all the day-to-day operations for this project. And with 17 states, you can imagine, like the day-to-day is a lot. So he provides all the instructions to all of the cooperators. And then this is us at Commodity Classic last year. So a lot of this biological seed treatment work was funded by a state checkoff. So in Ohio, that would be Ohio Soybean Council, but other states got funding from their individual state boards. So we're really appreciative of that state funding for this project. So I think that's it. And I have time for questions. Any questions about biologicals? Yeah. Yeah, Yep, so that's a good question about our baseline seed treatment. So our baseline was fungicide, insecticide, and that's because we wanted to be representative of what most people will purchase and buy for soybeans. So usually when you purchase soybean, it does have that baseline fungicide, insecticide application for sure. I know slugs can be a problem in Ohio and other states, such as like Pennsylvania. So slugs can be a problem, and I know, I haven't done the research, but I know there's evidence out there if you drop the insecticide out of your seed treatment, it can help with your slug populations because that insecticide can harm your beneficials that would hurt your slug population. So that was outside the scope of this research, but you're absolutely right. In a case where you have slugs and slugs are an issue, dropping that insecticide is one potential tool for that.
Well, this coming year, can you conduct this trial with the second component of untreated seed?
So this year, no, because my seed is already in the bag, right? So our seed is coming, but yes, yeah. For this biological project, we wanted to be most representative of what was going on in the U.S., but absolutely, you could potentially drop out your seed treatment and test the biologicals.
My novice experience would be that you're going to get totally different results when you use untreated seed.
Yeah, it's possible if you use completely untreated seed, you could get different results. We're just trying to be representative of the state. Yeah, so that is a great question, great comment. So the question was, did we document soil temperatures and other things? So we did not document soil temperatures, although we do have weather stations out. And I guess what's kind of important with this piece of research I presented is very preliminary or basic. It's yield. But from all of these locations, 49 locations, we have planting date, we have weather data, we have baseline soil test data for pH, CEC, we have stand counts, we have nutrient samples that are coming, we're doing protein and oil in the seed. So this is going to be a huge data set. When you work with 17 states, I won't name names, but we have some states that give me data on December 1st, and it's perfect, and it's done, and it's complete. And then I have some states where I'm still trying to beat the information out of them. So, again, I won't name names, but it's a very big effort to compile all of this, and with our statistician that we hired, we're hoping we can do some more analysis to try to tease that out. Because I think, just for one instance, soil test phosphorus. Soil test phosphorus is going to influence these microbes potentially. My student Fabiano, he's taken a class in plant pathology, and one of the microbes, if your soil test P is too high, instead of being a benefit to the plant, it may actually harm the plant because the plant it doesn't need help to get phosphorus because there's enough phosphorus in the soil. So those are the things that we really need to tease out with this data set, and it's coming. But that's a very good question.
All right, thanks again to Laura.
Mm-hmm.